But we're going to shift gears a little bit in this series, and we're going to talk about commercial fueling. My name is Ed Kammerer, and I'm the Director of Global Product Management here at OPW. And today we're going to talk about above-ground storage tanks, or also referred to in our industry as ASTs. In the retail videos, we talked about underground storage tanks, or USTs. But in the commercial setting, we typically find above-ground storage tanks, or ASTs. And there's a number of reasons for that. When we talk about commercial fueling, what we mean is the fueling of fleet vehicles, municipalities, cities that fleet or fuel their city vehicles, police cars, fire trucks, those types of applications. So one of the differences between a retail fueling and commercial fueling is the volume of fuel that's pumped. So many commercial fueling sites don't need the large underground storage tanks that you would find at a retail gas station. So they tend to use smaller tanks. The other reason is sheer cost. Above ground tanks, they're simple to install. They can simply be set on a concrete pad, on a saddle somewhere on site, where the underground storage tanks are very large, so it requires a lot of time and money to dig big holes and excavate, move a lot of dirt to bury these tanks. Regulations also play a key part in the reason to go to an above ground storage tank versus an underground storage tank. The underground tanks tend to be a little bit more heavily regulated, trying to protect fuel and gasoline from leaking into the ground, where an above ground storage tank still has regulations, but they're not quite as harsh as the underground environment. If you think about an above ground tank, if it leaks or something goes wrong, it's very easy to visually see that tank is leaking versus relying on expensive equipment to monitor the tank while it's underground to determine if there's a leak or a problem with the tank. Underground storage tanks typically come in one shape. They're big cylinders, usually 8 to 10 foot in diameter, and then they vary in length, anywhere from 8,000 gallons to 20 or 30,000 gallons. But above ground storage tanks come in all sizes and shapes. They can be square, they can be rectangular, they can be cylindrical, they can be mounted horizontally, they can be mounted vertically, and can vary in size anywhere from 250 gallons all the way up to 40,000 gallons. The ASTs can also vary in how they're mounted. The horizontal tanks can sit on two steel saddles. They can be mounted on a skid, so they're easily slid around from location to location, or they can be built on site. The large vertical tanks are just mounted on a big concrete pad with maybe a concrete dike surrounding them. So there's many different ways, not only of the shapes and sizes of the tank, but actually how they sit on location, or if they're actually going to be mobile fueling above ground tanks as well. Where the underground tanks are typically made of fiberglass, or they're made of steel and then encased in fiberglass, most above ground storage tanks are made of steel. Now they can be constructed in many different ways, where it can be a single wall tank, they can be a double wall tank, similar to the underground tanks that we talked about, or they could be a single wall tank and then they're built inside a containment dike to help capture any liquid that may leak if the primary tank is ruptured. There's a number of regulations that determine what type of above ground tank you can put on your site. These can go anywhere from state regulations, but most of them depend on the local regulations or what the local authorities will allow you to set on your property with an above ground storage tank. If you think about it, because these tanks are above ground, they're exposed to many more things versus tanks that are buried in the ground. They can be exposed to fire, they can be hit by vehicle traffic. Many different things can affect these tanks because they are sitting above grade. So many local authorities will require the tank to be fire rated or follow the NFPA 30 code. We talked about NFPA 30 in the retail videos. NFPA stands for the National Fire Protection Association, and they write a series of codes that helps protect flammable liquids and vessels that contain flammable liquids. So tank manufacturers will actually make a flame shield or a fire guard tank. And the way this is done is it's a double wall steel tank, but the space in between the primary tank and the secondary tank is filled with something to help protect that inner primary tank from a fire or a flame. In the old days, the tanks used to be filled, that interstitial space was actually filled with concrete, but the concrete was heavy, it would crack, the tanks were hard to transport. So now most of the fire guarded tanks, that interstitial space, or that space between the primary and the secondary, is made with some type of fire insulation. It's much lighter and actually provides a better protection should that tank be exposed to fire over long periods of time. Most of the fire shield tanks are rated against 2 hours against a fire or a flame. Just like our underground storage tanks in our Retail 101 videos, our above ground storage tanks are basically doing the same thing. We're moving a liquid from point A to point B, and the tanks serve as our storage vessel at point A. These tanks store our diesel, our gas, our fuel oil, any of these flammable liquids that we're going to move from a storage facility into an actual vehicle. Now that tank, just like our underground tank, for that to happen requires three things. You have to be able to fill that tank, you have to be able to empty that tank, and then that tank needs to be able to vent or to breathe. So we'll talk about those three things and how they affect an above ground storage tank. Okay, so filling our AST can be accomplished in a number of different ways. Usually on the smaller tanks, it can be as simple as an opening right on the top of the tank, a 2-inch opening or a 4-inch opening, where a transport truck brings a nozzle, sticks in the hole, and fills up the tank. Now on larger tanks, most of the fills are done with what we call a direct fill. And this would be an adapter mounted on top of the AST, similar to the adapter that we find in our underground storage tanks, where a tight connection would be made by a drop elbow or a large nozzle that seals tightly on this adapter and fills the underground tank. Now again, based on the size of the tank and what the local or state requirements are, this fill point also may be required to have some type of containment, or what we call spill containment. On our underground storage tanks, we put a spill bucket in the ground where that drop is made. And similar to the above ground tank, or similar on the above ground tank, we have a spill container or a spill bucket. Again, it surrounds the fill area, and that way when the connection is undone, any drips or spills will be collected in the bucket rather than spilling on the outside of the tank. Once the fuel is in the bucket, then it can be either drained back into the tank or it can be pumped out and disposed of. The other way that the ASTs can be filled is with what we call a remote fill. This would be an area away from the tank, or it can be mounted on the side of the tank. And again, we would have a spill container. These would typically be like a metal box, and there would be the same type of tight fill adapter in that box where the driver would make his connection, and then the fuel is actually pumped up a series of piping and then down into the tank. So we have direct fill or remote fill, which is done outside of the tank. Now the other requirement that you may have when filling your AST, and again this depends on the size of the tank, could depend on the state or the local requirement or regulation, is the tank may have to have some type of overfill protection. The spill bucket gives us overspill protection, but you may also need overfill protection. Just like an underground storage tank, what we use is an overfill prevention valve. And that's a valve that goes down into the tank, and then normally there's some type of float mechanism that's mounted on that valve, and when the product in the tank reaches a certain level, the float will come up, it'll activate a poppet or shut off the flow of product, and that keeps the tank from being overfilled. Okay, so let's talk about the number of ways that we can empty our AST, or how we get fuel from our tank into our vehicles. There's a number of different ways to accomplish that. It can be as simple as gravity. You'll see this on many farms sometimes. An above ground tank will be mounted up on a high stand, and then there'll be a hose coming out of the bottom of the tank, and you fuel your vehicle, or when you open your nozzle, gravity from the tank simply makes the product flow out the end of the nozzle. Another way is to mount what we call a transfer pump. These are usually 110 volt small pumps, anywhere from a 0.5 horsepower to 1 horsepower, and they'll be mounted on the tank. They'll have a small motor in them, and then the hose and nozzle will be off that transfer pump, and you'll fuel your vehicle by activating the small transfer pump. The other way is a cabinet pump. Similar to the transfer pump, it may be a small cabinet type that's mounted in the tank. Again, it pulls or sucks product from the tank through a small hose and nozzle into your vehicle. The other way that we can move product from our AST to our vehicle is with a suction pump. This would be a pump either mounted on what we call a pump porch. A pump porch would be a pedestal, usually comes off the side of the tank, and then a suction pump that looks similar to the gas pump you see at a retail station, actually has a suction pump inside of it, and it'll pull product from the tank through the pump. It can be metered, and through the nozzle or through the hose and the nozzle into the vehicle. And finally, the last way would be similar to an underground storage tank, where you can actually mount a large submersible pump on top of the tank. And again, the submersible pump would pull product from inside the tank and then push it to a series of dispensers. Usually if there's more than one fuel island associated with the what's coming out of the tank, you'll have that set up. That one submersible pump can feed multiple dispensers, so you can feed multiple fuel islands with one product from one tank. And lastly, let's talk about how this tank vents, or how it breathes. Because we pump product in and constantly take product out, you need to be able to vent that tank, or the space inside that tank needs to be able to breathe. So similar to an underground storage tank, if our tank contains diesel fuel, we would simply have just some type of open vent to the atmosphere. It usually has some type of cap or cover on it to keep rain from getting in the tank, or sometimes you'll see a U-shaped piece of pipe that again just is open to the atmosphere and allows that tank to breathe. Now if we're storing gasoline in our tank, similar to our underground tank, we need to have some type of pressure vacuum vent. These vents actually would be mounted on a pole or a steel pipe that comes from the tank, and either the open vent or the pressure vacuum vent is required to be at least 12 feet from the grade of where the tank sets. But for filming purposes, we're going to show this on top of the tank. So again, a pressure vacuum vent actually has a weight and a spring. So when the tank reaches a certain pressure, the weight will lift up and allow the tank to breathe. Or as you're pulling product out of the tank, you build up a vacuum inside, and when that vacuum reaches a certain level, the spring opens up and allows atmosphere to enter in the tank, and it keeps that tank from either exploding or imploding. So when it comes to venting ASTs, we have to do something a little bit different than what we do on USTs. If you think about it, USTs are buried in the ground, so they're not exposed to big temperature swings, and they're not exposed to things like fire and other things that can happen outside the tank. With an above ground storage tank, again, we're out in the environment, so it can be exposed to big swings in temperatures, and it can also be exposed to fire and other natural hazards. So what's required on ASTs, in addition to some type of pressure vacuum vent or open vent, is what we call an emergency vent. This would be a way to evacuate the tank or evacuate the pressure from the tank in the event of an emergency. It's going to be a high buildup of temperature, due to the sun or perhaps a fire. But because there's flammable liquid inside the tank, if it reaches a certain high temperature quickly, we could have an explosive situation on our hands. So the above ground tanks require some type of emergency vent. There's a couple different ways that these are made. A lot of times it's what we call a mushroom style vent, where there's a weight on here that lifts up when the tank reaches a certain pressure. It can be a flapper on a spring-loaded vent that will open when the tank reaches a certain pressure. Now, there's a way to determine what size emergency vent that your tank needs, and it's based on the capacity of the tank. It's based on the wetted surface area of the tank, and then that'll determine how big this vent needs to be. This one here is a 4-inch. These can go anywhere up to 10 and 12 inches, and then again the weight depends on the capacity needed, and we measure that venting capacity in CFH, or cubic feet per hour, and that's the amount of air, free air, that can be moved in a cubic foot per hour. So again, that determines the size and the weight of our emergency vent, and that's calculated by the size of the tank and the wetted surface area of the product in the tank. Okay, so let's talk about the additional equipment or accessories that you may see mounted on top of your AST. If our AST contains gasoline, just like our underground tank, when we fill the tank with product, there's gasoline vapors inside the tank, and as the product fills in that tank, that vapor is displaced and goes out of our pressure vacuum vent. But we actually want to have a way of capture those vapors rather than just shooting them up in the atmosphere and causing pollution. So your above ground storage tank, if it contains gasoline, will also be required to have a stage 1 vapor recovery. And this would be an opening in the tank with a separate adapter. The driver, when he fills the tank, will hook a hose up to the adapter underneath here. He'll hook the product hose up, and as the tank is filled with product, the vapors that are actually in that space, or we call the ullage of the tank, those vapors actually go up through the hose and back to the transport truck, where they can be taken back to the terminal and reprocessed, versus those gasoline vapors just going up in the air and causing pollution. Now, if we have a diesel tank or a fuel oil tank, because diesel doesn't vaporize quite like gasoline, that stage 1 vapor recovery is not required. Now, many times we may want to know how much product is actually in our AST, which is one of the advantages of having an AST. If my tank's underground, I have no way of just visually looking at that tank and determining how much product is in. I have to rely on an electronic tank gauge. But ASTs, because they can be viewed, many tanks will have some type of visual gauge. And the way these work is there is a float in the tank, and as that float goes up and down with the level of product that's in the tank, it's associated to a dial or a gauge, or this can be sometimes a clock gauge, and by simply looking at that gauge, it'll tell us the level of product inside of our tank. Okay, in addition to having a visual gauge that shows us the product level in the tank, you also may want to have some type of an alarm. Now these alarms can do two different things. They can sound off when the product reaches a high level in the tank, or maybe you want to set the alarm to go off when it reaches a low level or you're about to run out of fuel in your tank. And actually, again, depending on the size of the tank and the location of the tank, an overfill alarm may be required. So these can be as complicated or as complex as the systems that we find in underground storage tanks, which comprise of a probe, a magnetic probe, with a float level that's wired back to a console inside of a building or a back room somewhere. Or with an AST, it may be as simple as a small audible alarm, again with a high level float or a low level float. These can be battery operated or they can be wired, hardwire, but it can be an audible alarm that simply goes off and gives the operator a warning, again, that his tank may be about to be filled or his level in his tank has reached a point where he wants to get product because it's reached a low level. The other piece of equipment that you may see mounted on your AST is what we call an anti-siphon valve, or an ASV. The anti-siphon valves are used when we have a suction pump. Like we talked about, it's one of the ways that we can pump fuel from our tank. The suction pump can either be mounted right on the back side of the tank, or maybe it's remoted or set somewhere remotely, and there's piping that runs from the top of the tank down to grade level or below ground, and then runs over to where that suction pump is. And what the ASV, or anti-siphon valve, is designed to do is there is a spring-loaded poppet inside that valve. So while the suction pump is not being used, the valve is shut, so product can't flow through. As soon as the suction pump is turned on, the pipe reaches a certain pressure, and the valve will open and allow product to flow. Now the reason that valve is in there, if you think about this, because you're piping from a high location to a lower location, if something should happen in that pipe, if that pipe should break somewhere below the level of the surface, it creates a siphon, and the product could be pulled out of the tank and the whole tank could be siphoned out. Where with this, because the suction pump is lost or it's no longer pulling, the spring closes the valve and won't allow the tank to be siphoned completely by a break in the line between the tank and the suction pump. So the anti-siphon valve comes in different settings, and that setting is basically determined by the amount of head pressure that may be in that tank or in that line. And it's a simple calculation by determining the height of the highest point of the piping versus the lowest point of the piping. You can calculate the head pressure, and that'll tell you what size valve or what size spring goes in your anti-siphon valve. Or some anti-siphon valves can actually be adjusted in the field based on the head pressure from the top of the pipe to the bottom of the pipe. Okay, so that wraps up our AST, or above ground storage tank, portion of this series of commercial videos. Again, AST versus UST, still very similar. The tanks can be manufactured either with a single wall or a double wall, but because our ASTs are mounted above ground and exposed to many different dangers that our below ground environment doesn't see, there are some unique pieces of equipment and applications and construction for our ASTs. I hope this video has helped point out some of those things and gives you a little bit better understanding of the equipment on an above ground storage tank. And also, please check out our series of videos on retail fueling, and then now our series of videos on commercial fueling. Again, I'm Ed Kammerer with OPW. Thank you.